guys, welcome back to my YouTube channel. Today I'm going to explain about this LeetCode hard problem subarray with k different integers. So this is an hard problem in the LeetCode. Before going to the problem, I would like to request you guys, if you are not subscribe my YouTube channel, please subscribe my YouTube channel and support me, guys. Yeah, let's go to the problem statement. First, let's see the problem statement first. Given an integer array nums and and an integer k, return the number of good subarrays of nums. Okay, did you get, guys what they are saying? Given an integer array nums and an integer k, return the number of okay return the number of good subarrays. Okay, good subarrays. A good subarray means, yeah, let's see that. A good array is an array where the number of different integers in that array is exactly k. Okay, a good array means is an array where the number of different integers in the in that array is exactly k. For example, let's see. So they are also given the one example for that good array. For example, 1, 2, 3, 1, 2 has three different integers. Okay, this is an array has three different integers 1, 2, 3. So this is an good array. And also one more thing, guys, they mentioned sub arrays. What is mean that sub arrays? A sub array is an contiguous part of an array. Okay, contiguous part of an array. First, let's see that. What is that? What they mentioned? Subarray. Subarray. So subarray means contiguous part of array. Contiguous part of an array. Let's see that. So there is an array 1, 2, 3, 4, and 5. Okay. Contiguous part of an array means 1 is an subarray, 1 comma 2 as a subarray, 1 comma 2, 2 comma 3 one subarray, 1 comma 2 comma 3 comma 4 comma this is an subarray. 1 comma 2 comma 3 comma 4 comma 5. This is also one subarray. So these are the contiguous subarrays. Okay, not only subarrays, these are the contiguous subarrays. But 1 comma 3 comma 4, this is not an subarray. 1 comma 3, this is also not a subarray. Okay, and 1 comma 5, this is also not an subarray. They are expecting contiguous flow. Okay, contiguous flow, not in the middle, not in the last. So they are expecting the contiguous flow. Okay, that is called as an subarray. Okay, understood, you guys? Yeah. Let's see that next problem. So already they have given the example here. Here they have given the inputs, some inputs here, and the output should be like 7 in the single number. Explanation is they also given subarray format with exactly two different integers 1 comma 2 2 comma 1 1 comma 2 2 comma 3. These are the subarrays in this from this array with the k distinct element. Okay, so remember this, guys. They are saying k different elements. Okay, k distinct elements. Okay, not k size. They are not expecting the k size of the subarrays. They are expecting the k distinct integers. You see, guys, they are given the 2 comma 1 comma 2. So here there is three elements, but the k is 2. They are not expecting the k size. They are expecting the k distinct elements only. So in this subarray, how many elements are there? I mean, distinct elements. So 2 is there, 1 is there. So those are the two distinct elements. Yeah, we are also looking for that. K is also 2. Okay, so that's why this is the one of the subarray of good array. Okay, subarray, and also this is also a good array. Yeah. For this, first of all, what we have to do in the initial level, already you got one logic in your mind. What is that? First, find the subarrays. Okay, find the subarrays. Okay. First, and next step is what? Find the k distant elements of the k distant elements of the subarray. Yeah. But problem is if you follow these steps, okay, if you follow these steps, so for this first step, find the subarrays. First is find the subarrays. So it will take big of n square. Okay, big of n square, and also finding the k distant element of the subarray means that will take big of n. Okay, completely it will take big of n cube. Okay, n cube. So this is very slow. So this algorithm is very slow. Okay, because suppose if we have 20,000 elements in the array, so just observe it, guys. So it's taking big of n cube time complexity. Okay, if you do this, if you apply this logic to the 20,000 elements, so how much it will take to execute the problem? So it will take a lot of time, na? So for that, instead of that, finding the subarrays and after that finding the k distant elements, first, instead of finding the exactly k distant subarrays, just find the at most k distance elements. After that, find the at most k minus distance elements. So just find the at most k subarrays count. Find the k minus 1 subarrays count. So what we need exactly? Sorry, exactly k distance elements now. So for that, first find the at most k distance elements minus at most k minus 1. Why I'm using this logic? Because find the k distance elements in that some subarrays are include this at most k minus 1 subarrays also include in this at most k subarrays. So for that, so we don't need this k minus 1 subarrays. So for that, we have to remove that k minus subarrays. So that's why I'm removing that count. So in that whatever include this at most k minus 1 elements, I'm removing that k minus 1 subarrays from this k subarrays. Okay, if you find this, if you find this, then we will get the exactly k subarrays. So those are distinct elements. Those subarrays are contains the distinct elements. Okay, na? K distinct elements. That is the logic. Let's see the pseudocode for this. In this, I'm following the sliding window concept plus frequency map. Okay. Sliding window, you also know how about it, and also frequency map. So this is for find the frequency of elements, how many times that element was repeated in that array. So that we can find with the help of this map. Okay. And the sliding window is a window. It is a window-based concept. Like let's see that here we have to take the already we have one element like a k element. Just we have to take the window size is k. Okay, and we have to take two concepts k size and also k minus 1 sizes windows. Two windows we have to take and we have to find that good subarrays. Okay, with the k and with k minus 1. So just subtracted those counts. So then we will get the k distant subarrays. Okay, k distant subarrays count. Yeah, let's see the first of all. Let's see that algorithm. This first what we have to do. First, we have to use the sliding window concept. No, okay. Sliding window. Here I'm taking k two variables. like left and right. In the sliding window, normally we take left and right. I'm starting from 0. Right also I'm starting from 0. Okay. This is an array. Let's consider as in this is an array. Left and right. Okay. I'm starting from 0. 0th index. Okay. And another one thing is map. This is where store the frequency of the elements. Okay. First, let's consider one example here. 1, 2, 1, 2, 3. 1, 2, 1, 2, 3. Okay. This is an array and k is equals to 2. Yeah. First we have to use the sliding window. Start from this. Right is equals to 0 to this nums. Sorry, this nums. Nums is nothing but a array dot length. Okay, array dot length minus 1. Okay, after that I have to loop it for right is equals to 0 to array length. Okay, in that first find the frequency map. For that we have to use the map. So what we have to do? Nums of right, let's find this frequency. If it is not there, just increase it. Okay, add it and increase it. And nums of right is in the default you have to take 0. If it is there, any value is there, just to increase that value. Okay. If the map size is one condition, you have to write while condition. Map size is map dot size is less than k. Sorry, greater than k. Then we have to decrease that. We have to decrease the left element. Okay, we have to remove that because if we want to move forward, just we have to remove the previous first element. So for that, what we have to do? We have to decrease the element. Nums of left 0 is not there. Just if it's there, any frequency, just remove that, decrease it, and if that map dot get of nums that element is equals to 0. Okay, that frequency is 0. Just remove that remove that element from map of left. Okay. So yeah, we have removed the left element. What we have to do next? We have to increment it this left element. Okay. So increment the left element. Then after that, what we have to do? We have to find the subarrays. Total subarrays. So total. So for this, here initialize the one total variable here 0. In the initial level 0 value is there. Then after that, what you have to do? Total plus is equals to right minus left plus 1. Why I'm using this? Because find the subarrays. How many elements, how many subarrays are there at that index? Okay, if we stop the to the indexed, second indexed, so then the left value is 0 in the initial level. If I stop the second index, then 2 minus 1 plus 1. How many subarrays we will get? 2 subarrays. Okay, 2 subarrays. For example, 1 comma 2 comma 3. 0, 1. Sorry, left is 0. 3 subarrays we will get here. For example, we will get this 3 subarrays with k distinct elements. So for that, so what is that? 1 comma 2 comma 3 and another one is 1 comma 2 comma 3. So yeah, we need count now. So for that I'm using this logic here. We are getting the 3 subarrays. Okay. We find the we are finding the indexed subarrays. Indexed subarrays. How many subarrays are there at that stopped index? Okay. For that I'm using this right minus left plus 1. Clear the guys? Yeah. So this is an algorithm for that. Let's see the with help of the one example, then you can easily understand it. First, in this logic, what we have to do? First, we have to find instead of finding the exactly k distant element, I have to find at most k and minus at most k minus 1. Okay. First, find the at most k distant element. Okay. For that, k is 2. And array is 1 comma 2 comma 1 comma 2 comma 3. Okay. Yeah. Now let's see the map. The map is empty for in the initial level. Right is that is equals to 0. So 0, 1, 2, 3. Here from I'm starting from 0th index. So and I'm storing those values in this map. So just consider this one as first I'm storing from this logic, from this pseudocode, consider first we have to start from 0th index, and if it is just store that value into the map and increase the frequency. Okay, here I'm starting from the 0th index, and 0th index 1 value is there. So that value frequency is 1. Okay, and for moving forward, right is equals to first 1 and 2 also is there, 1 and 1 right is equals to 2, 1 is there, 1 is there, so repeated here 2, and after that right it is equals to 2 is also increases, and the right is equals to 3. What is that? Sorry, this is also 3. Right is equals to 4. 3, 3 element, and that frequency is 0. That problem is, what is that algorithm is saying? While map size is greater than k. Map size is greater than k. Now map size is 3 and k value is 2. So 3 is greater than 2. So this condition is true. So for that, what we have to do? Sorry, yeah, we have to decrease that value. Decrease the first value. Okay, here left is 0. Okay, left is there. Okay, right is here right now. Okay, what we have to do? We have to decrease that value. So in the left position in the map, sorry, in the array, what value is there? I mean, nums of 0th index, 1 is there. So we have to decrease that frequency. Okay, we have to decrease that frequency. We are decreasing here. Okay, and again we have to check this condition. While map.size is greater than k, yes, it is true. Again, it's true. Okay, still 3 value is there. So what we have to do? We have to same thing. We have to decrease this value. Okay. Then now one frequency is 0, and there is a condition. So if the frequency is 0, if the value of frequency is 0, what we have to do? We have to remove that value from the map. We have to remove this one value from the map. Yeah, we have removed that. Next, what is that next? After removing the element, what we have to do? We have to increment it. We have to increase the left value, left index. Okay, now this one removed, okay, from the map. Next, this left variable point in the second element. Okay, second element. I mean 2. Then now what we have to do? We have to find the total. Total we have to find. Sorry guys, I forgot it to tell you. So in the after while storing this, we have to find the total. So for that, just simple guys. One thing. While right is equals to 0 at that moment, at the left is left also 0. Then the total is 0 minus 0 plus 1. Total is 1. And after that, right is equals to 1. That moment, total is 1 plus the right is 1, left is 0, it's 1. So that 1 plus is equals to 1 plus 1, 2. Then the value is 3. And after that, right is equals to 2. Then 2 already 3 value is there. 2 minus 0 plus 1. 3 plus 3 is equals to 6. Okay? And after right is equals to 3 and left is equals to 0. 6 plus or equals to previous total is 6. So 3 minus 0 plus 1, 6 plus 2, 4 is equals to 10. Okay. Finding this at most, for this at most k, we will get 12 subarray. Okay. For this at most k minus 1, we will get 5. So what we need exactly k distance. So 12 minus 5 is how much? The result is 7. Yeah. Let's see the logic here. Then you can understand it. So first what we have to do, we have to initialize it. Left is equals to 0 and in total is equals to 0. For int, I'm using the sliding window for this. So for that, right, is less than nums dot length. Okay, right plus plus. Okay, in this, what we have to do, we have to first initialize the map. Integer comma integer. The map will store the objects. Map is equals to new hash map. This hash map. First, we have to store the map frequencies. First, we have to find the frequencies of that array while using this sliding window. What we have to do, nums of right comma map dot get or default of right comma 0 1. Okay, while map dot size is greater than k, what we have to do, we have to decrease that. And output nums of right comma map dot get or default nums of right comma 0 minus 1. One decrease in that frequency if the map size is greater than k. And after that, if that map dot get nums of right, sorry, what we have to do, left one, we have to decrease the left one, not right left. And I have to check this condition for the left value. If that element frequency is 0, then what we have to do, we have to remove that element from the map. Okay, for that I'm using the remove method in the map dot map of. After removing the that element, left element, we have to give the left variable position. What we have to do, increase that left element. Okay, after this, find the total while inserting the map. While inserting the values into the map, we have to find this total. Total is equals to it minus left. How many subarrays is there at that right index from left? Okay, at that I'm using this logic, and after that, if I look after this, return the total. Okay, total. In the initial level, I told you what we have to do. Find the at most k subarrays and at most k minus 1 subarrays. So for that, what we have to do, complete this logic, we have to store in one particular function. For that, we have to find the exactly k distance element of subarrays count. So for that, most so nums comma k minus most nums comma k minus 1. Okay, in this function, just we have to store this complete logic, whatever we wrote previously. It will also return the integer at most. Int is an array. Okay, nums comma int. That's this left increment. We have to write this after this if condition. Okay, let's see the execution of this. Yeah, let's submit it. This is an logic for this. I hope you understood the logic. So okay. Thank you guys. Thank you for watching this video. If you like this video, please like it and comment it if you need any here. I would like to create another video for this problem on another programming language. Like here I have solved with Java. If you are comfortable with any other languages, please let me know guys. I will create another video for that. Yeah. Thank you guys. Thank you for watching this video. If you are not yet subscribed my YouTube channel, please subscribe my YouTube channel. Yeah. Thank you guys.